10.2 Vector Operations. So before we dive into example 3 and example 4 and get into derivatives soon, we need to first talk about the different operations that come with vectors. The first thing we're going to start with is when multiplying a number into a vector, this number is called a scalar. So if I did 3 times a vector, the scalar would be 3. It's very similar to a coefficient when you talk about like 3x and 5x, it's the number in front of the variable. So in these next examples, we're going to let the u vector be u1, u2, so any just points x and y, and the v vector be v1, v2, again, any x and y coordinates. We're also going to let k be any scalar. So the first thing we're going to go ahead and start with is vector addition. So when you do vector addition, it's pretty easy. The vector u plus the vector v is you just add the x components and you add the y components. Multiplying by a scalar, also pretty easy. You just distribute the scalar into each component. So if you had the vector 3, 5, and it was multiplied by the scalar 2, it would become the vector 6, 10. The opposite vector is known as the vector when you multiply by -1. So if you had the vector 1, 1, your new vector would be -1, -1. Vector subtraction, again, pretty easy. All you do is subtract the components. The unit vector is when you take a vector and make it magnitude 1. So then that would mean basically you take the vector and divide by the magnitude, which is going to force it to just be 1, 1, but it'll put it in the correct direction. And you can get that by just doing cosine of theta and sine of theta because the magnitude is 1. And that'll give you what's called the direction vector because the magnitude is just 1. Now we're going to talk about how to add vectors graphically. So there's 2 ways we do this. One is called the parallelogram method and the other one's called head to tail. So to do this, I'm going to actually pull up a graph and we're actually going to just see a couple of these work out. So what I'm going to do is I'm going to start with 2 vectors. This one is u and this one is v. And again, all I'm doing, I'm just giving them names so we can kind of talk about them. And so what I want to do is I want to add u to v. And one way to do that is to make a parallelogram and then find the diagonal. So if I were to do that, my parallelogram would look like this. And then if I inserted the diagonal, it would be this. So then my vector u plus v would be this vector here, which goes to the point 4, 3. So if I take the vector 1, 2 and add it to 3, 1, 1 plus 3 is 4, and 2 plus 1 is 3. Another way you can do that is called the head to tail method, which is the one I prefer. So let me turn off these extra vectors and show you what I'm talking about. So what we're going to do here is we're going to start with u, and then we're going to add v. So v goes to the right 3 and up 1. So I'm going to just start at the end of u, and I'm going to go to the right 3, 1, 2, 3, and I'm going to go up 1, 1. And this should give me the ending point of my new vector. So let's see if we did that right. Let me turn the extra ones off and turn the right one on. Yep, and this was right. This is my new vector, so if I turn everything off except for the sum, I get that this is my new vector. Subtracting is also pretty easy. All you have to do when you subtract is, well, subtract. So instead of going up 1 and over 3, I'm just going to reverse everything. So if I want to do u minus v, I'm going to start here at the end of my first vector, and I'm going to go left 3, 1, 2, 3, and down 1. So this is the ending point of the result. So if I put the subtraction on, there you go. So u minus v will be this vector here. And you can do that mathematically by doing 1 minus 3 is negative 2, and 2 minus 1 is 1, so my new vector should be negative 2 comma 1. And again, that's just the head minus tails method. Another thing that we can do is do scalars. So for example, if I wanted twice this vector, if I wanted twice u, it's literally just twice its length, because you just multiply each component by 2. If I wanted negative 2u, you just multiply each component, 1 comma 2, by negative 2, and you get the negative vector. So these would be some graphical representations of vectors with their scalar multiplication. If you just start with u, half of u has the same direction but half the magnitude. 2u has twice the magnitude but same direction. And negative u would have the same magnitude but different direction because now it's negative.